this problem is pretty much the same as that last problem. Of course, different numbers. But now they're not giving us a picture. Now, if it helps you to draw a picture, then feel free to do it. So I guess I can do that. But in fact, before I do that, let's go through this. So it says one of the legs of a right triangle is 7 centimeters, and its hypotenuse is 18 centimeters. So I know first that I have a leg that's going to be 7 centimeters, and then I have a hypotenuse that's going to be 18 centimeters like this. So just knowing that we have the Pythagorean theorem right here means that if you wanted to, you could put those values in. Now the leg being 7 centimeters, doesn't matter which leg you make it. I'll make it the first one again, just because I'm doing it randomly. And then the hypotenuse being 18 centimeters means you could put that in right there. Now again, if you need a picture, then feel free to draw it. Again, I'll just kind of pattern it after the ones we just did. But if that is the case, I would probably make this one a 7, and then this one can be an 18, like this. Is it drawn proportionally? I don't know, but I also don't care. What I noticed, though, is that I'm missing a leg length, which they said find the measure of the missing or other side length. The leg length, dang it. So, now that I have that, of course, I would square the 7 and the 18, and it would look something like this. So 7 squared plus the missing leg squared, equals 18 squared. And I know 7 to the power of 2, that's going to be old 49er. But 18 to the power of 2, I don't know what that is. So in my calculator, 18 to the power of 2, enter, and I get 324. Okay, so now the equation becomes 49 plus leg squared equals 324. We are solving for that missing leg. And right now it's to the power of 2, which is okay, but that means I've got to use the principle of equality here in order to take that leg squared and just be able to drop it. Because I don't want that 49 with it, and we see addition, meaning we're going to have to zero values out. So I'm going to have to minus 49. If I do it to one side, I must do it to the other side. Once again, there's no expectation that you do this in your head. So on the calculator, I've got 324 minus 49, enter, and I get 275. And as planned, 49 minus 49 is 0, so it's gone, which is what we want. The last thing here I want is a regular leg, not a leg to the power of 2. So I'm going to take leg squared and square root it. If I do it to one side, I must do it to the other side. But then again, this goes back to the calculator. I got the square root of 275, enter, and this is the number I get from my calculator. Right? So this is the number I get. It will be in centimeters, but it says again that we need to round this to the nearest tenth. So I will. And this will give me, again, it's a leg. It's the same leg, it's just we're rounding it to the nearest tenth. Right here, my 5 here is in the tenths place value. The 8 to the right is 5 or more. So I'm going to have to add 1 to that 5 in order to make this a 6. So I end up with 16.6. I'll label it in centimeters because it's a word problem, and if I have labels, I should label it. 16.6 centimeters, that is all. And so, of course, if you wanted to come back here and put in your 16.6, you could. Centimeters, centimeters, centimeters. There you go. So it's about 16.6 centimeters. I mean, you get in the hundredths in centimeters, and it's pretty small, but that'll do.